Hello everyone. Good evening. Hope you all are doing great. First of all, please let me know am I audible? Is my voice okay? Please let me know in chat. Yes. Yes. Okay. So today we are going to understand routing fundamental. Before starting routing, I would like to discuss packet flow between two computers in same network and packet flow over router. Then we will come on routing. Before discussing routing, you have to understand how router build routing table, how router takes forwarding decision, these things. So without wasting our time, let let's start the session. Let me share the screen with you and let me continue. Yes, CDP, can I start? So I have shared my screen. Built. Now hope my screen is also visible to you. If yes, please let me know in comment. Yes, great. So see, suppose I have two computer, this one and this one. Both are directly connected with each other through one Ethernet cable. Through one Ethernet cable, both computers are directly connected with each other. Now for basic communication, we have some requirement like both PCs need one MAC address, need one IP address on their NIC card, then only they can communicate with each other, right? Let's say this is computer A, this is PC A, and this is PCB, or suppose this is MAC address of PC, MAC address of computer one is A and MAC address of this computer is B, right? Let's say IP address of computer A is 10.1.1.1, and this IP address belongs to class A. By default, network ID of this IP address is 10.0.0.0. Hope this is clear to everyone. If you have joined last class, IP address of this computer is 10.1.1.2. Fine. Both computer belongs to same network because network ID of both computer is 10.0.0.0. Here we can say /8, and here also we can say /8. Means subnet mask is 255.255.0.0.0. So if computer A want to communicate with computer B, right? If computer A want to communicate with computer B, computer A need source IP address, destination IP address. Let me write, these are four basic requirement of communication. Source IP, source IP, then destination IP, then source MAC. This is destination, then source MAC, and then finally destination MAC. If computer 1 want to communicate with computer B, computer A need source IP address that is 10.1.1.1, destination IP address that is 10.1.1.2, source MAC, let's say that is A, and destination MAC that is B. Fine. So see, if computer A want to communicate with computer B, let's say computer A want to ping computer B to check connectivity. Is there connectivity between computer A and B or not? For that, on computer A in command prompt, you will type this command ping and then destination IP address, IP address of computer B, that is 10.1.1.2. So you will run this command, right? Then this computer A will came to know that destination IP address is 10.1.1.2. Destination IP address is 10.1.1.2. What will be the destination IP in packet? 10.1.1.2. Who tell to this computer? You, right? You tell to this computer ping this IP address 10.1.1.2. That means 10.1.1.2 is destination over here. Now this computer need MAC address of 10.1.1.2. Computer A need MAC address of 10.1.1.2. So for that, this computer will check their ARP table, ARP table. So each computer, whenever, always keep in mind, whenever we configured IP address on NIC card, on the computer NIC, computer will start maintaining one table called ARP table. Once you will assign one IP address to interface, machine will start maintaining a table called ARP table. So both machine, like PC1, this is, let's say, ARP table of PC1, and this is ARP table of PC2. Both machine will maintain one ARP table, ARP table. I will show you these things practically also, don't worry. Here, this is ARP table of PC2, ARP, address resolution protocol table. In this ARP table, PC1 will make one entry that my IP address is 10.1.1.1 and my MAC address is A, right? So when I will ping 10.1.1.2, PC1 will look up their ARP table to find MAC address of 10.1.1.2. So see, inside the ARP table of PC1, there is no any entry available for 10.1.1.2. There is no any entry available for 10.1.1.2. Right? There is no any entry available in the ARP table of PCA for 10.1.1.2. Right? Then this PC will do one thing. Whenever a device need MAC address from IP address, whenever a device need MAC address from IP address, machine generates one ARP request message. ARP request message. See, ARP is a protocol, guys. ARP is a protocol which is used to resolve MAC address from IP address, which is used to resolve MAC address from IP address. Like here you can see PCA know what is IP address of destination device, that is 10.1.1.2, but machine A don't know what is the MAC address of 10.1.1.2. So this PC will generate one ARP request message. It will generate one ARP request message. This is ARP request message, right? ARP request, ARP request. Inside the ARP request, it is asking what is MAC address of 10.1.1.2. What is MAC address of 10.1.1.2? When PCB will receive this ARP request, PCB will came to know that someone is trying to know my MAC address. So PCB will generate ARP reply message. This PC will generate ARP reply packet. ARP, this is ARP reply message. Reply message. Fine. And inside the ARP reply message, PCB will share their MAC address. It will say my IP address is 10.1.1.2 and my MAC address is B. My MAC address is B. Now, when PCA will receive this ARP reply message, it will make one entry in their ARP table that IP address is 10.1.1.2, whose MAC address is what? Whose MAC address is B. Whose MAC address is B. Right? And now you can see whenever now this PC need to forward some data to 10.1.1.2, they can find what is the MAC address of 10.1.1.2 in their ARP table. Right? In the same way, in the ARP table of computer B, there will be one entry like my IP address is 10.1.1.2 and my MAC address is B. And then PCB need to know what is the MAC address of destination device. For PCB, destination is PCA. So what is the MAC address of 10.1.1.1? So what PCB will do? Again, PCB will generate one ARP request message. After that, PCA will generate one ARP reply message, and then PCB can learn what is the MAC address of 10.1.1.1. That is A. Now both PCs know what is the MAC address of destination device. Now they can communicate with each other. So let's say you are pinging to 10.1.1. Once you will hit this command in command prompt, ping 10.1.1.2. Ping works on ICMP protocol. ICMP is a layer 3 protocol which is responsible for reachability. To check reachability, we are using ICMP protocol here. So when I will run this command in the prompt, this PC will generate one ICMP request message. This PC will generate one ICMP request message. ICMP request message. request message. And at layer 3, ICMP protocol will hand over this request message to IP protocol at layer 3. As you know, at layer 3, at network layer, IP protocol work. And IP protocol is responsible to add IP header. Inside the IP header, there will be information about source IP and destination IP. So IP protocol will add one header here. And inside that header, there will be information of source IP and destination IP. So source IP is 10.1.1.1 and destination IP is 10.1.1.2. There will be these two information. There will be some more information as well, but these two are very important, source IP and destination IP. After that, IP protocol will hand over it to lower layer, means to data link layer. Now data link layer will add source MAC and destination MAC. It will add source MAC is A, source MAC is A. Then data link layer need to add destination MAC, so it will look up their ARP table. Inside the ARP table, yes, there is one entry is 10. What is the MAC address of 10.1.1.2? So MAC address of 10.1.1.2 is B, so destination MAC is going to be B, right? And then data link layer will hand over it to physical layer. After that, physical layer will transmit this ICMP request message from the link on the cable. And when PCB will receive this ICMP request message, PCB will generate one reply message. Fine. This is how packet is going to flow between two computers. Now, see, if in this scenario, my destination belongs to my network. My destination belongs to my network, same network. Now, what will happen if destination belongs to different network? Let's say, let me create another scenario here. In this scenario, I have one PC here. I have another PC here. And between PC1 and PC2, I have one router. I have one router here. Let's say this one router. And PC1 is connected with router 1. Like this. This is my router R. This is, let's say, PCA, and this one is PCB. Fine. IP address of this PC is 10.1.1.1. And here on the router interface, IP address is, let's say, 10.100. And IP address of PCB is 20.1.1.1. And IP address on this router interface is, let's say, 20.100. So this time you can see if 10.1.1.1 want to ping 20.1.1.1, this time destination belongs to different network. This time destination belongs to different network. So whenever destination belongs to different network, then PC will generate ARP request for default gateway. For default gateway, let's say this is fast Ethernet 0/0 F0/0 of this router, fast Ethernet 0/0, and this one is, let's say, fast Ethernet 0/1. Fine. This is fast Ethernet 0/1. Here MAC address is, let's say, C, and MAC address of this interface is, let's say, D. So if 10.1 want to ping 20.1, if here I will type this command, ping 20.1.1.1. What this PC will do, this PC will generate one ICMP request message first. ICMP request message. This is, let's say, ICMP request message. After that, ICMP protocol will hand over it to IP protocol. IP protocol will add one IP header. Inside the IP header, there will be source IP and destination IP. Source IP will be what? 10.1.1.1. And destination IP address will be what? 20.1.1.1. This time destination belongs to different network, not same network, because network ID of source is 10.0.0.0 and network ID of destination is 20.0.0.0. Both are different. So this time at layer 2, when IP protocol will hand over it to layer 2, means network layer will hand over it to layer 2, data link layer. Data link layer need to add source MAC and destination MAC. Source MAC is going to be what? A. And destination MAC. For destination MAC, this PC will check what? ARP table. Inside their ARP table, if there is no any entry for default gateway, what is default gateway of this PC? 10.100. So this PC is going to send frame on destination of default gateway. destination of default. Destination will be MAC address of default gateway. So this PC will generate ARP request for default gateway for 10.100. And 10.100 means router will generate ARP reply message. In the ARP reply message, it will share their MAC address. So here destination MAC is going to be what? C. Right? Destination MAC is going to be C. After that, data link layer will hand over it to physical layer, and physical layer will forward it to router. Now router will check layer 2 information first. In layer 2 information, it will check destination MAC address. So destination MAC address is C. C is the MAC address of their interface. That means router will came to know that someone have sent this frame message for me. Let me check further information, means upper layer information. Then this router will check layer 3 information, destination IP address. Destination IP address is 20.1.1.1. That means this packet is not for me. This packet is for 20.1.1.1. This router will remove this layer 2 header from here. It will remove this layer from here, and after that it is going to add one new header here. In the new header, source MAC is going to be MAC address of their exit interface, that is D, and destination MAC is going to be MAC address of destination device, because this time destination belongs to same network from router. So destination MAC will be B. And after that, router will exit this packet from fast Ethernet 1/0, and this is how computer B will receive ICMP request message. And in the same way, computer B will generate ICMP reply message. And after that, you will see the ping is successful. Now I am going to perform this lab, right, in packet tracer, just to show you how packet is going to flow between two computers. So see guys, here, let me take two computer first, computer 0 and computer 1. Let me correct it. Let's say this is computer 2 and this is PC 1. Fine. Let me connect these two devices together. Now what I need to do, I need to configure IP addresses on this machine. So first let me configure one IP address on PC1. IP address on PC1 is 10.1.1.1. Subnet mask is 255.0.0.0. Here default gateway is not required because destination belongs to same network. When default gateway is required, when destination belongs to different network. Fine. So now on PC2, let me configure one IP 10.1.1.2. Subnet mask is same 255.0.0.0. Now if you will check ARP table of PC1, ARP table of PC1, let me run one command here, ARP-A. You can see ARP table, no ARP entries found. In Windows operating system, computer does not carry their own MAC address and IP address, their own MAC address and IP address. But in Cisco iOS, a device carry or keep information of their own IP address and MAC address also. Right here you can see ARP table of PC1 is empty, there is no any information. In the same way, you can check ARP table of PC2 also. ARP table of PC2, let me show you, command prompt ARP-A. You can see ARP table. There is no MAC address of 10.1.1.1 on PC2. So what will happen when I will ping 10.1.1.2, means this PC from PC1? Let me write here IP address. IP address on this PC is 10.1.1.1 and IP address on this PC is 10.1.1.2. Fine. And you can see the MAC address also, like here. If you want to see MAC address, you can check the MAC address on fast Ethernet 0. You can see this is MAC address of this PC. This is MAC address of this PC. Fine. Now let me show you here. Let me open simulation mode, and now we can see the packet also. See, I am going to ping PC2 from PC1. From PC2, I am going to ping PC1. So ping, let me run this command, ping 10.1.1.2. Ping 10.1.1.2. See, once I have hit enter on this PC, you can see there are two packets. There are two packets. One is ARP packet and one is ICMP packet. So R packet, if I will open this R packet, you can see the information inside this R packet first. See, information inside R packet. Source IP address is 10.1.1.1. Hope it is visible to everyone. Is it visible, guys? So here source IP address is 10.1.1.1 and target IP address is 10.1.1.2. That means this ARP request is looking for MAC address of 10.1.1.2. What is the MAC address of 10.1.1.2? And target MAC address is 0.000. That means don't know what is target MAC address. Target IP address is known. Target MAC address is unknown. Right, so this PC will send this ARP request message to PC2. Now PC2 will generate one ARP reply message. PC2, it will drop this ARP request and then it will generate one ARP reply message. See what happened here. Let me correct it. I think there is some error. ARP request ICMP. I think IP address on PC2 is incorrect. Yes, it is 21. Let me correct it. 10.1.1.2. Now you can see ARP reply message. This is ARP reply message. If I will open ARP reply message, inside the ARP, this is ARP request. Let me generate ARP reply. Yes, this one is ARP reply. PC2 have sent this ARP reply message to PC1. If I will open this message, so here you can see target MAC address is unknown. Target IP address is 10.1.1.2. This is not really ARP reply message. I think there is some error. Just wait, guys. First, I will check ARP table again. ARP-A. Inside the ARP table, now there is one entry. There is entry MAC address of 10.1.1.2 is this one. MAC address of 10.1.1.2 is this one. This PC have learned what is the MAC address of 10.1.1.2. What I can do here, I want to show you ARP request message and reply message. Let me check ARP table of this PC, ARP-A. Here also we have one entry. What is the MAC address of 10.1.1.1? This is MAC address of 10.1.1.1. So now PC1 know what is the MAC address of 10.1.1.2 and PC2 know what is the MAC address of 10.1.1.1. Guys, there is some error in output, in the packet output, but thing is going to be same. First PC1 will send ARP request to PC2, and then PC2 will generate ARP reply for PC1, right? And after that, it is going to send ICMP message. And now if I will ping PC2 from PC1, let me check ping is working or not. So you can see ping 10.1.1.2. So PC1 is not able to ping 10.1.1.2. Yes, PC1 is able to ping 10.1.1.2. Right? Now what I am going to do here, let me connect one router also. This time I have one router here and I am going to connect two PCs. PC2, this is PC1, this is PC2. Fine, let me connect the devices. Yes, now I am going to configure IP addresses like on router interface. Here I will configure 10.1.1.1. Here I will configure 10.20.1.1.1 and here I will configure 10.1.1.10. Here I will configure 20.1.1.10. This is my IP configuration. First, I am going to assign IP on PC 1, 10.1.1.10, and default gateway. This time I need to define default gateway because see, this both PC belongs to different network. So default gateway is 10.1.1.1. Fine. On PC2 also, I will do same thing. Here I will configure one IP 20.1.1.10. Default gateway is 20.1.1.1. Now I need to configure IP on routers, on router interfaces. So let me configure IP on router interfaces now. So on fast Ethernet 0/0, on fast Ethernet 0/0 interface, fast Ethernet 0/0, I'm going to assign IP address 10.1.1.1 and say subnet mask 255.255.255.0.0.0 and say finally no set. Here, exit. Interface fast Ethernet 0/1. On this interface, I'm going to say IP address 20.1.1.1, 255.0.0.0, and finally say no set. No set. Fine. Now, on the router, if you will check ARP table, command is show ARP. Inside the ARP table, you can see there are two entries. Their own IP address on fast Ethernet 0/0, their own IP address on fast Ethernet 0/1. As I told you, that Cisco IS will carry their own IP address and on MAC address also in their ARP table, but PC does not carry these information, means their own IP address and MAC address. Fine. Now, on PC1, if I will check ARP table, sorry, ARP hyphen A, so you can see ARP table is empty. PC1 want to communicate with PC2. So PC1 need what? IP address of PC2 and MAC address of their default gateway. So if I will ping 20.1.1.1, ping 20.1.1.1, and let me open simulation mode here. Once I will hit enter, again this PC will generate two packets. One is R packet, and one is ICMP packet. R packet is, see, inside the R packet, target IP address is what? 10.1.1.1, means default gateway. Okay, so this PC will send this ARP request message to router. Router will generate ARP reply message. And now this PC will send ICMP packet to router. After that, router will forward it to PC2. This is ICMP packet. It is forwarding. Which type of message it is? What is ICMP packet? I think I have been 20.1.1.1 from PC1. Ping is working, but we are not able to see packet between router and PC2. This is problem of packet erasure. But now, if you will check ARP table of PC1, ARP ARP-A, so you can see inside the ARP table, there is MAC address of default gateway only. Still, this PC is able to ping. 20.1.1.1, because in the actual ICMP packet, destination MAC will be MAC address of default gateway, right? Not MAC address of destination device, that is 20.1.1.1. Fine. In the same way, on PC number 2, if you will check ARP table, on PC2, you will check ARP table, ARP-A. You can see there is no any entry. There is no any entry here because I have just 1 second. Yes. So now if I will ping 20.1.1.10 means PC2. So this time ping will work. Soon we will get reply message. Yes, you can see ping is successful. And now if you will check ARP table of PC2, again ARP-A, you can see entry is for default gateway. This is MAC address of default gateway. Means PC1 don't know what is the MAC address of PC2. PC2 don't know what is the MAC address of PC1. Each know what is the MAC address of their default gateway. And whenever PC1 need to forward packet in different network, they will forward packet to their default gateway at layer 2. Their responsibility is to forward packet to their default gateway at layer 2. Now it is responsible, default gateway is responsible to forward this packet to next device, right? So this is how packet is flowing between two computers if both are directly connected with each other in same network, or when both are in different network. Now guys, see one thing. Router, you know how router forward packet with the help of routing table. Router forward packets on the basis of routing table. Whenever router will receive any packet on fast ethernet 0/0, this is fast ethernet 0/0 interface, and this is fast ethernet 0/1 interface. So when this router will receive any packet on fast ethernet 0/0, it will compare what is destination IP address in the packet. So inside the packet, destination IP address is 20.1.1.10, let's say. Then router will compare that destination IP address with their routing table. This router is going to check their routing table. Inside the routing table, there should be one route for destination network. So see, so IP route. This is command to check routing table. Inside the routing table of router 1, there are two network. One is this one 10.0.0.0/8, and another one is 20.1.1.0/28, right? This there are two network in the routing table of router. There are two network in the routing table of router, and both are directly connected. This C means connected network. C means connected network, and this L is locally, means local IP address. This is IP address and this is network ID, right? So one network is connected on fast ethernet 0/0, that is 10.0.0.0/8, and one network is connected on fast ethernet 0/1, that is 20.0.0.0/8. Fine. So whenever router will receive any packet, let's say this router is receiving one packet from any on any other interface where destination is 10.1.1.1. So if destination is 10.1.1.1, so this destination will match in this entry. That means router will forward packet from fast ethernet 0/0. If destination is 20.1.1.1, then destination match in this entry. Router will forward that packet from fast ethernet 0/1. Right? This is how router takes forwarding decision. Now question is how router build routing table. So when we are configuring IP address on interfaces, router makes one entry in the routing table for that network, like that network is directly connected on that interface. When I have configured IP address on fast ethernet 0/0, router have make one entry in their routing table, that what is the network ID of this IP address. You have configured this IP 10.1.1.1 and subnet mask. With the help of network ID and subnet mask, router will calculate network ID, and they will make one entry in their routing table that that network is directly connected on fast ethernet 0/0. When you will configure 20.1.1.1 on fast ethernet 1/0, in the same way router will calculate network ID, and it will make one entry in their routing table that that network is directly connected with fast ethernet 0/1. Right? This is how router build routing table. This is how router build routing table. Any question till now? Is it clear? If it is clear, please let me know, guys. Now I have, let's say, different scenario. My scenario is bit different. Let's say I have two router here. Are router 1 and router 2, and two switches are there. Let's say this is switch 1, this is switch 2. Two switches are there, and both switches are connected with end devices like computer, printer, those things. So let's say here we have some computers, and here also let's say we have some computers. There are lots of devices and devices. Okay, all are connected through switch. All are connected through switch. All end devices are connected through switch, and switch is connected with routers like this, and both router are also connected with each other. Let's say this is R1, R1, this is R2, this is switch 1, and this is switch 2. Fine. Let's say here we are running one network, that is 10.1.1.0/24, or let's say 192.168.10.0/24. We are running this network over here, and here we are running this network 192.168.20.0/24, and between router 1 and router 2 we are running, let's say, 2L network, 12.1.1.0/24, 12.1.1.0/24. Here IP address is, let's say, 12.1, here IP address is, let's say, 12.2. Here IP address is 12.2. Now, in this scenario, if PC1, let's say this is PC1, 2, 3, 4, 5, 6. IP address of PC1 is 10.1, means 192.168.10.1, and PC4 IP address is 20.1, means 192.168.20.1. Here on this interface, let's say on this interface of router IP address is 10.10, on this interface of router IP address is 20.10, 20.10. Now, see, in this scenario, if I will talk about the routing table of router 1, so tell me guys, how many network will be there in the routing table of router 1? How many network will be there inside the routing table of router 1? 3 networks? No. Why 3 networks, brother? 2 networks. One, because only 2 networks are directly connected with each other. Only 2 networks are directly connected with router 1 and router 2. Like when I will configure IP address on this interface, let's say this is fast Ethernet F0/0, this is F0/0, this is F0/1, this is also F0/0, and this is F0/1. So when I will configure IP address on fast Ethernet 0/0 of router 1, let me, this is routing table of router 1, let's say, and this is routing table of router 2, let's say, right? So when I will assign IP address on fast Ethernet 0/0 of router 1, router 1 will make one entry in the routing table that there is one directly connected network with symbol C. C means directly connected. Which network? Network ID of this IP address which you have assigned to interface. Network ID will be 192.168.10.0. So this network is directly connected on which interface? On fast Ethernet 0/0. On fast Ethernet 0/0. Correct? Right? After that, when I will assign IP address on fast Ethernet 0/1, again it will make one entry. One network is directly connected, that is 12.1.1.0, and this network is directly connected on which interface? On fast Ethernet 0/1. In the same way, inside the routing table of router 2, there will be 2 entry. When I will configure IP address on fast Ethernet 0/0, it will make one entry like C, and network is 192.168.20.0. This network is directly connected on fast Ethernet 0/0, and one more network is directly connected, that is 12.1.1.0. On which interface? On fast Ethernet 0/1. Right? This is routing table of router 2. This is routing table of router 2. So you can see both router have their routing table. In their routing table, directly connected networks are there. Now what will happen if 10.1 want to communicate with 20.1? Sir, our request will only generate first time before connecting, or every time if it will generate? See, whenever destination MAC address is unknown, then PC will generate ARP request message. ARP request message. Let's say a PC need to forward one packet to any destination, and PC will look up their ARP table. Inside the ARP table, if entry is not available, means MAC address is not available of destination device, PC will generate ARP request message, right? Once PC will learn MAC address of destination device, it will keep that entry in their ARP table for 300 seconds. After 300 seconds, it will flush the entry. That means if a device is communicating with another device after 300 seconds, then that device need to generate ARP request again. There is no any difference between ARP request in ARP request between PC to PC and PC to router. ARP request and ARP reply is going to be same in both scenario. Yes, means if after 5 minutes it will generate ARP request again. Now in this scenario, if 192, this PC1 want to communicate with PC4, what will be source IP address? You tell me. When PC1 want to communicate with PC4, source IP will be what? Source IP will be what? What will be source IP? PC1 want to communicate with PC4. Please let me know what will be the source IP address in the packet. What will be source IP address? 190, very good. 192.168.10.1. What will be destination IP address? 192.168.20.1. Destination IP address will be the IP address of destination device, not default gateway. MAC address will be the MAC address of default gateway. If I will talk about layer 2 information, so at layer 2, source MAC will be the MAC address of PC1 and destination MAC will be the MAC address of default gateway, right? Now in this scenario, at layer 3, source IP is 192.168.10.1, destination IP is 192.168.20.1. This PC will forward this packet to router. Now when router will receive this packet, what router will do? What router will do? Router will compare destination IP address with routing table. Router will compare their destination IP address with routing table. So see, when router will receive this packet on fast Ethernet 0/0, it will come check destination IP is what? 192.168.20.1. Let me check my routing table. Inside the routing table, is there any entry available for destination network, guys? Is there any entry available for destination network in the routing table of router 1? Yes. No. No. No, no, no. You people are saying yes. How, brother? See, the routing table of router 1 is in front of you. Inside the routing table of router 1, there are only two networks, 192.168.10.0 and 12.1.1.0. There is no any information for 192.168.20.0 network. So simply router 1 will drop this packet here. Router 1 will drop this packet. Drop this packet. Okay. Router 1 will drop this packet. In the same way, if PC4 will generate any packet, router 2 will drop the packet, because when PC4 will generate a packet for PC1, destination IP address will be 192.168.10.1, and there is no any entry available for this network in the routing table of router 2. So this time router 2 will drop the packet. Then how PC1 and PC4 can communicate with each other? Then how PC1 and PC4 can communicate with each other? Actually, we have to tell to routers. Means I have to tell to router 1 about 192.168.20.0 network, and I have to tell to router 2 about 10.0 network. Because see, 192.168.10.0/24, this network is unknown for router 2. This network is unknown for router 2 and this network is unknown for router 1. So we have to inform router 1 and router 2 about these two networks. And this is called routing. This is called routing. Routing means selecting path from source to destination is called routing. See, between source and destination, let's say 192.160.10.0/24 is source and 192.168.20.0/24 is destination. Between source and destination, now route is not available. Route is not available, because of that 10.1 10.0 cannot communicate with 20.0. 10.1 cannot communicate with 20.0. So here we need to tell to router 1 about indirectly connected network. Indirectly connected, because by default both router know only directly connected network. Both router knows only directly connected network, they don't know indirectly connected network. So we have to tell to router about indirectly connected network. Now we have multiple method to configure route in the routing table of router. Like inside the routing table of router 1, I need to inject one network. I need to inject one network. Which network? 192.168.20.0. This network. I need to inject this network in the routing table of router 1, and I need to inject this network 192.168.10.0 inside the routing table of router 2, right? So I need to inject one network in the routing table of router 1 and one network in the routing table of router. And as I told you, we have now various options for routing. Selecting path between source to destination is called selecting path between source and destination is called routing. Now we have two types of routing, static and dynamic. We have two types of routing, static and dynamic. In static routing, manually we will configure route in the routing table of router. Manually we will tell to router 1 that there is one network. See, for static routing, symbol is S. S means static route. Statically we have configured this route. Statically we will tell to router 1 that 192.168.20.0 network is reachable from which interface? From fast Ethernet 0/1. I am telling to router 1 that whenever you need to forward traffic in this network 192.168.20.0 network, you should forward packet from fast Ethernet 0/1. In the same way, on router number 2, I will configure this route S and 192.168.10.0/24. 10.0 is reachable via which interface? Fast Ethernet 0/1. It is reachable via fast Ethernet 0/1. Now, if I will again ping PC4 from PC1, if I will again ping PC4 from PC1, PC1 will generate this ICMP request message. Inside the ICMP request message, source IP address is going to be 10.1, destination IP address is going to be 20.1. Again, router 1 will receive the packet and it will compare destination IP address with routing table. So destination IP is 20.1, 192.168.20.1. It will compare this destination IP address with routing table, and this time router 1 have one route for this network. And this network is reachable from fast Ethernet 0/1. So router 1 will forward this packet from this interface from fast Ethernet 0/1 to router number 2. When router 2 will receive this packet, it will again check destination IP. It will compare destination IP with routing table, and inside the routing table, yes, there is one route available for this network 192.168.20.0 is directly connected on fast Ethernet 0/0. Is directly connected on fast Ethernet 0/0. That means router 2 will forward this packet from fast Ethernet 0/0, and when PC4 will receive this packet, it will generate ARP reply message. Sorry, ICMP reply message, right? This is what static routing. In dynamic routing, what will happen? We will configure one process on router. We will configure one process on router. According to that process, router is going to exchange their routing table with each other. Like router 1 will share their routing table to router number 2, router 2 will share their routing table to router number 1, and both can learn in directly connected network with each other. Okay, so this is a static routing. Routing means selecting path between source to destination. There are two types of routing, static and dynamic. Now we are going to perform on a small lab on a static route, and then we will see dynamic routing in upcoming days. Fine. So guys, there are two methods to configure a static route on router. One, Static route with exit interface. Like here I have configured a route with exit interface. Like exit interface for you will be fast Ethernet 0/1. And on router number 2 also exit interface for this network is fast Ethernet 0/1. Exit interface for this network is fast Ethernet 0/1. So here I have configured static routing by using exit interface. Or what I can do, I can tell to router 1 that this network 192.168.20.0 network is reachable via next hop IP address. Next hop IP address means next hop for router 1 is router 2 and next hop for router 2 is router 1. In this scenario, next hop of router 1 is router 2 and next hop of router 2 is router 1. So I can configure like 192.168.20.0/24 network is reachable via 12.1.1.2 IP address of next hop. IP address of next hop. So either I can configure a static route by using exit interface, or I can configure a static routing by using next hop IP address. By using next hop IP address. Or the third method is we can assign both. We can define exit interface also and next hop IP address also. Because if we will configure a static route with exit interface, router will consider that network directly connected. If I will configure a static route with next hop IP address, there is recursive problem, recursive lookup. Router need to check their routing table twice. Again, this is problem. So generally, we are configuring a static routing by using both exit interface and next hop IP address. Let me configure a static routing, by using these all method in packet tracer. In packet tracer, or I can open GNS3 also. Let me open GNS3. That is good. For routing, I recommend GNS3. For basic practical, you can use packet tracer. Let's say I have some router 1, router 2, and there are two switches. This is GNS3. Is GNS3 screen visible? Are you able to see the topology which I am designing here? I think you need to exit and rejoin the session. If you are facing issue, please exit and rejoin the session. Please guys mute yourself. Okay, this is my topology. Here in this topology, see what I am going to do. First of all, I will configure IP addresses. Here I am going to configure 12.1.1.1 IP address. Here I am going to configure 12.1.1.2 And here I am going to configure, let's say, network. Which network? 192.168.10.0/24. And this side I'm using 20.0/24. Fine. Let's say default gateway IP address. Let me assign default gateway IP address also. Here IP address is, let's say, 10.10, and here IP address is 20.10. 20.10. Now let me configure the scenario. Let me access devices. This is router 1. First of all, let me turn on the device. R1. R2. PC1. PC2. PC3. And PC4. Okay. So let's start from router 1. On router 1, let me assign IP first. Config T. Interface fast Ethernet 0/0. Say no set. And IP address 192.168.10.10, 255.255.255.0. Exit. Then interface fast Ethernet 1/0. Say no set here also. And IP address 12.1.1.1, 255.255.255.0. Exit. Now here I can verify the IP configuration. So also IP interface brief exclude unassigned. You can see I have assigned this IP address on fast Ethernet 0/0 interface, and this IP address on fast Ethernet 1/0. And so IP route inside the routing table of router 1 also, you can see there are two network. One is directly connected on fast Ethernet 1/0, that is 12.1.1.0/24, and one network is directly connected on fast Ethernet 0/0, that is 192.168.10.0/24. Now let me configure IP on router number 2. Interface fast Ethernet 1/0, say no set. No set. IP address 12.1.1.2, 255.255.255.0. Exit. Interface fast Ethernet 0/0. Say no set here also. And IP address 192.168.20.10, 255.255.255.0. Done. So IP interface brief exclude unassigned. Okay, IP configuration is done on router number 2 also. And so IP route inside the routing table, you can see directly both are directly connected network, right? Now let me assign IP on PC also. On PC1, say IP 192.168.10.1, let's say here, /24, and gateway IP address is 192.168.10.10. Right, it is checking for duplicacy, and after that it will assign this IP address. Now so IP all. So you can see IP address on PC1 is this one. This is default gateway, and this is MAC address. Fine. Now on PC number 2 also I can configure IP 192.168.10.2/24, and default gateway is 192.168.10.10. Fine. Finally PC3 IP 192.168.20.1/24, and 192.168.20.10 is the default gateway. And finally on PC4, yes, done. IP 192.168.20.2/24, and default gateway 192.168.20.1, 20.10. Now I want to ask some question to you guys. Let me open chat here. Yes. Now first question is when PC1 will ping to their default gateway, means to 10.1. 10.10. 192.168.10.10. What will be the destination MAC address? MAC address of default gateway or MAC address of any other device? MAC address of 192.168.1.10. 1.10 or 10.10? Default gateway 10.10. Very good. When PC1 ping to PC2, then what will be the destination MAC? When PC1 ping to PC2, this is second question. 10.2. Very good. When PC1 will ping to PC2, destination MAC will be the MAC address of PC2, means 10.2. When PC1 will ping PC3, then what will be the MAC address? When PC1 will ping to PC3, what will be the MAC address? MAC address of which device? When PC1 will ping to PC4, MAC address of default gateway, very good. Correct. Fine. So this is clear. Now on router number 1, first of all, let me check connectivity between PC1 to PC3. Ping. I'm going to ping PC3 from PC1. Okay, let me ping first PC2 from PC1. Ping 192.168.10.2. Will ping work here? Will ping work? Works. No? Why no? Absolutely yes. Absolutely yes, and you can see ping is working. ARP then ping, yes, definitely. ARP-A, invalid command. So ARP, yes. Here you can see the MAC address of PC2. Fine. Now I am going to ping PC3 from PC1, 192.168.20.1. Will ping work? Will ping work? Yes, no, yes, no. Ping will not work. Now ping is not working. Now tell me the reason why ping is not working. Why ping is not working? We have to do routing. Exactly. Because when PC1 is pinging to PC3, source IP address in the packet is going to be 192.168.10.1 and destination IP address is going to be 192.168.20.1. Right? PC1 will forward this packet to their default gateway. Their default gateway will check their routing table and router 1 will compare destination IP address with routing table, and there is no any route available for destination network. There is no any route available for destination network. So here I need to configure one route. See how I will configure. In global configure mode, I will run this command IP route and then destination network. What is destination network? 192.168.20.0. Then subnet mask of destination network, that is 255.255.255.0. And after that, exit interface, that is fast ethernet 1/0. Because this network is reachable from fast ethernet 1/0. As you can see, 20.0 is reachable from fast ethernet 1/0. Once I will hit enter, and now if you will check routing table, so IP route, you can see inside the routing table now there is one new route with S symbol. S means static. S means static. Here also you can check. S means static. So this is a static route. 192.168.20.0/24 is directly connected on fast ethernet 1/0. What router 1 is saying? This network is directly connected on fast ethernet 1/0. This is not true. This is not true. So what will happen whenever router 1 need any MAC address of IP address from this network, router will generate ARP directly for the destination device, not for the default gateway. Because router 1 will think what? This network is directly connected with me. What if other routes exist? Exit interface is different. Suppose on R1 it is fast Ethernet 0/1, and on R2, if you will configure wrong exit interface, see what will happen here. If I will define this network 192.168.20.0 is connected on fast Ethernet 0/0, right? So router 1 will forward packet from same interface again, from this interface, right? But router 1 need to forward packet from this interface. So this will be the problem if you will configure wrong exit interface. Exit interface should be correct, right? So this is problem, guys, with in static routing by using exit interface. Router is thinking that network is directly connected with interface. Now on router number 2 also, so IP route in the routing table, 192.168.10.0 is not available, right? Because again this network is indirectly connected for router number 2. So here also we need to configure static route IP route 192.168.10.0, subnet mask 255.255.255.0, and then exit interface fast Ethernet 1/0. Once I will hit enter, this router will also make one entry in their routing table. So IP route, you can see S, static route. What it's saying? Directly connected on fast Ethernet 1/0. This is not true. Because of that, see, ping will work. Ping will work. Now, if I will ping, so you can see ping is working. But if you will check ARP table of router 1, ARP table of router 1, so IP, so ARP. Inside the ARP table of router 1, there is MAC address of 192.168.20.1, right? This is MAC address. But this is MAC address of 12.1.1.2. This is not the MAC address of 192.168.20.1. This is MAC address of 12.1.1.1. If you want to verify, here on router number 2, you can see so interface fast Ethernet 1/0, and we can say include BICE. You can see MAC address. This is MAC address on fast Ethernet 1/0 of router 2, and same MAC address router 1 have learned for this IP address 192.168.20.1. So inside the ARP table there is wrong information. If I will disable proxy ARP, this is because of proxy ARP. If I will disable proxy ARP, if on interface fast Ethernet 1/0, if I will say no IP proxy ARP, and on router number 2 also on fast Ethernet 1/0 interface fast Ethernet 1/0, no IP proxy ARP. I have disabled proxy ARP, and I am going to clear ARP table, clear IP ARP for 192.168.10.1, and so ARP. Now inside the ARP table, so ARP, inside the ARP table, you can see there is no any MAC address for 192.168.10.1. In the same way on router number 1, if I will clear ARP table, clear ARP, clear IP ARP 192.168.20.1. Now so ARP. Inside the ARP table, you can see there is no any entry available for 192.168.20.1. Now if I will try to ping from PC1 to PC3, you can see again ping is not working. This time I am getting request timeout error. Earlier I was getting destination unreachable error, and this time I am getting request timeout error. So whenever, see, earlier router was dropping the packet because router don't know the route for destination network. Earlier router have no information about the destination network. So router was dropping the packet and it was informing to PC1. But this time what is happening? This time my default gateway is generating the reply, but not because of route. Not because of route. I am getting error message because of router 1 is not able to resolve MAC address of this IP address. Router is not able to resolve MAC address of this IP address, because router 1 need MAC address of this IP address. Because see the routing table of router 1 is saying this network is directly connected, so IP route. Router is saying this network is directly connected, so it is generating ARP request, but router 2 is not generating ARP reply message, because router 2 is not 192.168.20.1, right? So router 1 is generating ARP request message for 20.1, but router 2 is not generating reply this time. But if I will enable proxy ARP, then router 2 will share their own MAC address instead of MAC address of 20.1. Router 2 will check that am I reachable with 20.1 or not. If I am reachable, then I can share my own MAC address. So router 2 will share their own MAC address to router number 1. It means whenever you need to forward packet to 192.168.20.1, you can forward packet to me at layer 2. Because of that, communication was happening. So this is problem with static route with exit interface. Again, I am going to enable proxy ARP. If I will enable proxy ARP, interface fast Ethernet 1/0 IP proxy ARP. If I will enable proxy ARP on both router, interface fast Ethernet 1/0 IP proxy ARP. And now again, if you will ping from PC1 to PC3, you can see ping will work. Just wait. Now let me check ARP table of router 1. So ARP. This time still this machine is not able to resolve MAC address. Now you can see ping is working. Ping is working. So you know in ICMP, in ping you will get two types of error. One is request timeout and one is destination unreachable. Destination unreachable means my default gateway don't know what is the route, right? And request timeout means I have sent the ICMP message but not getting reply message. Whenever you send ICMP request message, PC will wait for 2 seconds for reply message. Within 2 seconds, if PC will not receive reply message, it will give you error, request timeout error. Proxy means what? Proxy means, forwarding some information, forwarding their own information instead of someone else. This is first method to configure static routing. Now the second method is static route by using next hop IP address. On router number 1, first of all I am going to remove IP route. No IP route 192.168.20.0 255.255.255.0 and exit interface is fast Ethernet 1/0. I have removed this entry from here. So IP route, now you can see there are two directly connected network only, right? On router number 2 also I am going to remove a static route configuration. Say no IP route 192.168.10.0 255.255.255.0 and exit interface is fast Ethernet 1/0. So IP route, right? The two directly connected network, static route is removed. Now I am going to configure a static route by using next hop IP address. On router number 1, IP route destination network 192.168.20.0, subnet mask of destination network 255.255.0, and next hop IP address 12.1.1.2. See, if you will configure a static route by next hop IP address, how router is going to make entry in their routing table. So IP route. What this router is saying? Now this network is reachable via 12.1.1.2. 192.168.20.0/24 is reachable via 12.1.1.2. Is reachable via 12.1.1.2. But to forward packet, router need what? Exit interface. So again, router is going to check the routing table to find what is the exit interface if I want to forward traffic to 12.1.1.2. Because with the help of this entry, router 1 will came to know that this network is reachable via 12.1.1.2, right? So router 1 need what? Exit interface for 12.1.1.2. So exit interface for 12 network is fast Ethernet 1/0, and this time router 1 will generate ARP request for 12.1.1.2. But problem over here is router need to check their routing table twice, right? We don't have problem of proxy ARP here, but router need to check their routing table twice. On router number 2 also, let me configure a static route. IP route 192.168.10.0, 255.255.255.0, and next hop IP address is 12.1.1.1, right? So IP route, you can see this static route. This network is reachable via 12.1.1.1. Both router need to check their routing table twice. And now if you will ping PC3 from PC1, you can see ping will work again. See, ping is working. Yes, ping is working. Fine. But problem over here is both router is checking their routing table twice. Right? If I will disable proxy ARP, then also ping will work. Let me disable proxy ARP interface. Fast Ethernet 1/0, say no IP proxy ARP. On router number 2 also, interface fast Ethernet 1/0, no IP proxy ARP. Still ping is working, right? And this time in the ARP table of router 1, if you will check ARP table, so ARP, you can see there is no any entry available for destination for 192.168.20.1. Whenever router 1 need to forward traffic in this network 192.168.20.0 network, destination MAC will be always what? MAC address of 12.1.1.2, because that network is reachable via 12.1.1.2. So IP route, this network is reachable via 12.1.1.2. So whenever router check their routing table twice to forward packet, that is called recursive lookup. That is called recursive lookup. Exit interface is same interface of R1, and next hop is exit interface of R2, right? Yes. Okay. So here what we have issue is recursive lookup. So the best way to configure a static routing is configure a static routing with using both next hop and exit interface. First of all, I am going to remove this entry, no IP route 192.168.20.0, 255.255.255.0, and 12.1.1.2. Now do so IP route. You can see the routing table. Static route is removed. On router number 2 also, what we can say, no IP route 192.168.10.0 and 12.1.1.1, right? The best way to configure static routing is, see, on router number 1, I will configure static routing like this. IP route 192.168.20.0, subnet mask 255.255.255.0, exit interface fast ethernet 1/0, fast ethernet 1/0, and next hop IP address is 12.1.1.2, like this. Like this, if you will configure static routing, then see the routing table. So IP route. Inside the routing table, this time all informations are there. One for this network is reachable via 12.1.1.2, and exit interface for this network is fast ethernet 1/0. So exit interface is also there, and next hop IP address is also there. So that router 1 will not generate ARP request message directly for the destination, right? And there is exit interface also. In the same way on router number 2, IP route 192.168.10.0, 255.255.255.0, and exit interface is 12.1.1. Sorry, exit interface is fast ethernet 1/0, and next hop IP address is 12.1.1.1. So IP route. Fine. Correct. Okay. So this is a static routing. How we configure static routing. Right. Now we have what? Dynamic routing. In dynamic routing, what we will do, we will run a process on router, right? We will run a process on router, and according to that process, router is going to extend their routing table itself, right? So now if any question, guys, please let me know, because today we are not going to start dynamic routing. Today we understood routing, packet flow, and static routing. In next class, I will start dynamic routing. So this is all for today. Now, if anyone have question, you can ask, because if I will continue dynamic routing now, because we have only 10 to 15 minutes now, so we cannot learn anything in dynamic routing today, right? So in next class, we will start dynamic routing with RIP. Please mark exit interface on router number 1. See, on router number 1, for destination network, this network is destination network on router number 1. Like this network is indirectly connected network. So if router 1 want to reach in this network, they can reach from this interface only, right? And like router 2, when router 2 want to reach in this network, they can reach from this interface only. So this is exit interface for router number 2, and this is exit interface for router number 1. Disadvantage of static routing is, configuring in large network. We can configure static routing in a small network, but let's say we have thousands number of thousands number of networks, or 100 number of networks. Then you need to run 100 times this command: IP route, destination network, destination subnet mask, exit interface, next stop. So it is very complicated to implement in large network, right? Static routing is suitable for a small network only. Send us the setup for GNS3. I will share one video link to install GNS3. Let me share right now. No, you cannot use, generally we are not using, a static routing in ISP, and ISP network is very large. In this topology, yes, I have 2 network, but 3. That is different thing. Like ISP gives lease line on a static route, that is different thing. Or on broadband. You need a single IP address. But ISP are connected with each other. Like inside the ISP network, you will see 500 routers, 1000 number of routers, all are directly connected with each other. So number of networks are very large there. There we cannot implement a static routing. What is basic difference between a static routing and dynamic? In a static routing, manually network engineer define network. In dynamic routing, routers learn networks dynamically with the help of routing protocol. Static routing is suitable in a small network. Dynamic routing is suitable in large network. In a static routing, CPU utilization is very less, and in dynamic routing, CPU utilization is required. If I have one up address, how many networks should I create? I'm not getting your question, brother. Sir, suppose I have taken connection from Airtel in my company. They will provide me a static route connection. Right, sir. Right. Correct. Difference between static routing and dynamic routing I have defined. At the end, you will see, how complete networks look like. Here I am sending you link of video to install GNS3. Yes, this one. Through this link, you can install GNS3. Then how BGP, NAT, static, OSPF work together between WAN and LAN. So that's what I am saying. And in upcoming day, when you will learn dynamic routing, then you will understood how everything is working together. A router can have a static route also in their routing table. A router can have dynamic route also in their routing table. But if a router is learning same route from static also and dynamic also, then router will prefer static route. And now CDP network is sharing, a link to subscribe the channel, to subscribe, to share your, review, so that those guys can understand about the training that you guys are learning or not. Is it beneficial for you or not? For me, that's all for today. Thanks for joining. How can I block ICMP traffic? For that, we have ACL access control list. We will discuss in upcoming days. Yeah, lecture time will be same, 5 to 7 p.m. At same time, we will meet on every Saturday and Sunday.